How's it going? This is Kyle, and I'm going to be redoing homework 1 with an environment camera this time. Alright, so first I'm going to cover a function in which we make the helical curve real quick. So we're given a few constraints. So we want r to be 3, mz to be 0.4, and we're going to make t from 0 to 4 pi, and I'm going to use like 36 points. And that's just how many points on the curve are going to be plotted. So define our function curve. Our function is going to take in t, as I mentioned, r, and mz. Okay. And then we're given the equations, so x is going to be 3 times the cosine of t, and in which case 3 is the r we define. So x will be r cosine of t, y is r sine of t, and z is equal to mz times t. So r times, what did I say? Cosine. So x is equal to r times cosine t. Y is equal to r p sine t. And then z is equal to mz times t. As I mentioned earlier, we want to define t as evenly spaced variable, or an evenly spaced array of numbers from 0 to 4 times pi. And then I said I wanted to do 36 numbers, and that's just basically how smooth the curve's going to look. More would make it a smoother curve, but 36 is plenty. R is going to be 3, and mz is equal to 0.4. Back to our function, where we want to return our x, y, and z values. Oh, I didn't run my import, so giving me an error. Alright, should be good. Yep. Alright, so now we're actually going to want to call on the curve with the constraints we want and actually plot it. So the first thing I'll do is I'm going to want to store the returns as variables to plot. So I'll say x, y, and z and set it equal to the function I just made, where I'm feeding it t, r, and mz, which we defined up above. So now that defines our x, y, and z, and now we just have to plot. So figure equals make subplots. Then we want to add the scatter to it, so fig.add scatter 3-dimensional, in which x is equal to x, y is equal to y, and z is equal to z. And I want to plot it with lines rather than with dots, so node equal lines. Alright, there we go. And whenever I graph, I know I prefer the background to be dark, so to change that, just do figure.update layout, update layout, and then we're going to change the template to be Plotly dark mode. We'll run that. And yep, so now we have our helical curve, and it goes around twice in the circle, and that's because we made our range 0 to 2 pi. And this is what I talked about, how it's kind of like choppy, that's just the number of points. So if I go up here and say I make 100 points from 0 to 4 pi, it'll still go twice in the circle, but the curve will look a lot smoother, but it takes a little longer to run because it's plotting a lot more points. So for now we're just going to stick with 36, and that should be plenty. And there we go, so now we have our helical curve, and I'll get into the parts 1 through 4 of the homework in the next few videos.